So one of the biggest problems with neural networks, which is what today's AI systems are, is what's called catastrophic forgetting. You've probably heard of it before. It's when an AI suddenly forgets what it previously learned the moment you train it on something new. Essentially, today's AI systems can't truly learn over time. They can be retrained, sure, but they can't remember and adapt the way humans do. Every time you fine-tune them, it's like wiping its brain and starting over. Andrej Karpathy, co-founder of OpenAI and previous AI head at Tesla, has said this is one of the biggest bottlenecks to AGI right now, because no matter how big these models get, they still can't continuously learn. He also called current AI slop right after saying this though, so take that as you will. But even Elon Musk brought this up recently. He said the probability of Grok 5 reaching AGI is 10% and rising. Someone asked, will it have continual learning? And Musk replied, dynamic reinforcement learning is important. Then added that Grok 5, like smart humans, will learn almost immediately. But so far, that's all just talk. Because the only real progress we've actually seen on this problem comes from Google, who just dropped a research paper that might genuinely change everything. As the title reads, Introducing Nested Learning, a new ML paradigm for continual learning. Nested learning is a new approach to machine learning that views models as a set of smaller nested optimization problems, each with its own internal workflow, in order to mitigate or even completely avoid the issue of catastrophic forgetting, where learning new tasks sacrifices proficiency on old tasks. In simple terms, instead of one big brain trying to learn everything at once, Google is basically making a brain made of mini brains, each learning at its own speed. Some adapt fast, some learn slowly, and together they build a kind of memory system that doesn't wipe itself clean every time it learns something new. Google says that while we've seen huge progress in AI over the past decade, continual learning, the ability to keep learning over time without forgetting old skills, has been the one area that's still basically unsolved. They mentioned though that when it comes to continual learning and self-improvement, the human brain is still the gold standard. It adapts through neuroplasticity, the ability to literally rewire itself in response to new experiences and memories. Without that ability, a person would basically be stuck in the moment, like someone with anterograde amnesia. And current AI models are kind of the same way. Their knowledge is locked into two places, whatever's in their short-term context window and whatever they memorized during pre-training. There's no in-between. Now, you could just keep updating a model's parameters every time it learns something new, but that causes, as we know, what's known as catastrophic forgetting. It learns the new thing, but forgets the old. Researchers have tried to patch this with better architectures and smarter optimizers, but they've always treated those two things, the network itself and the algorithm that trains it, as separate. And that separation, Google argues, is exactly what's holding us back. So in their paper titled Nested Learning, the Illusion of Deep Learning Architectures, Google basically says, what if the model and the training process are actually the same thing? So here's what that means. Nested learning views an AI model not as one big learner, but as a bunch of mini learning systems, all nested inside each other, each with its own flow of information and its own speed of updating. Again, some parts learn fast, others learn slowly, and together they form a kind of layered memory system that can adapt without forgetting. That's what Google calls deeper computational depth, not just stacking more layers, but layers that learn differently over time. To make it clearer, Google compares it to how our brains handle associative memory, like seeing a face and remembering a name. They point out that even the training process itself, like backpropagation, can be thought of as associative memory. The model is constantly matching data to how surprising or novel it is, learning which information really stands out. And when you look at something like a transformer, each part, attention, feed forward, memory, is really just another one of these smaller memory loops, all updating at different rates. Google says that's exactly how our brains work too, multi-time scale learning, different parts updating at different frequencies. By controlling how often each piece of the model updates, basically its learning speed, they can order all those nested parts into levels, and that structure is the heart of nested learning. They then talk about how this idea changes everything, even the way we train models. This is a bit more technical, but they completely redefine optimizers, the algorithms that actually adjust a model's weights, as their own little memory systems. Instead of treating each data point separately, these optimizers can now remember relationships between data, which makes them more stable when the data is noisy or imperfect. And for the architecture itself, Google introduces what they call a Continuum Memory System, or CMS. In a normal transformer, attention is short-term memory, and feed-forward layers are long-term. CMS, though, connects those into a full spectrum, a smooth blend of memories updating at different speeds, from milliseconds to months, if you will, which gives the model richer, more human-like recall. And finally, to actually test it all, they built a new model called Hope, a self-modifying version of a memory-heavy architecture known as Titans. I think I might have covered Titans in a previous video, I honestly can't remember. But basically, Titans were designed to manage long-term memory. They work by storing information on how surprising or important it is, kind of like how our brains remember the weird stuff first. The problem was, Titans only had 2 levels of learning, short-term and long-term. So they could remember well, but couldn't keep improving how they remember, if that makes sense. That's what Hope fixes. It adds an unlimited number of learning levels, like stacking infinite layers of memory and learning. It can literally update how it learns, creating a continuous feedback loop. A model that tweaks its own learning algorithm as it goes, almost like a self-improving neural network. And it actually works. Hope beats Transformers, Titans, and Mamba 2 on multiple benchmarks. It has lower perplexity, higher accuracy, and better long context reasoning. And in the needle in a haystack tests, where the model has to find small details buried deep in huge chunks of text, both Hope and Titans performed almost perfectly, far ahead of older models like Mamba 2 and TTT. So in short, Google's showing a whole new way to build AI. Instead of separating what the model is from how it learns, they've merged the two. That might sound abstract, but it could be the key to solving AI's biggest flaw, forgetting. As they write here, we believe the nested learning paradigm offers a robust foundation for closing the gap between the limited, forgetting nature of current LLMs and the remarkable continual learning abilities of the human brain. So nested learning is still early research, and the results are not insanely impressive. But it looks like this is an actual concrete step towards AGI, or at least human-like learning. Let me know what you guys think in the comments though. Is this the real deal, or just more marketing hype? And as always, thanks for watching. If you enjoyed this breakdown, please feel free to drop a like. Hit that subscribe button if you're new, and I'll be catching you guys in the next one.